Okay, that was a cycle. We got the bright idea of putting everything into a plastic tub so we could set it up faster. You can see here pretty much everything is in the tub. When we carried it into the Clements Center to set it up, we just had to fish out this stuff, our push button for starting things, and we don't really need this if the operators are going to start it all the time. There's another push button on the control panel that will also start it. But here we got the push button and our connectors for track power and our track detector, which is a standard LGB 1700 track contact. They've been making these since the 1980s, although they don't make them anymore. It's a newer style they make now. And then the other thing we had to fish out was our 110 volt power connection. And what's inside the tub, we got our control panel over here on the left. And what's actually doing the controlling is an NCE mini panel. That's its technical name, an NCE mini panel. I call it a programmable model train controller because that's how we're using it here. And then what we call our status light is here that changes to from red to green as this operates in the power control panel, which is part of the NCE power cab. This is the power cab laying here, and in our speaker over here that's making that station announcement, which is obviously optional. You don't have to have that. Then there's an ESU sound decoder that's got the station announcements programmed into it. There's actually about six or seven different announcements programmed into that. In the NCE, the company that makes this DCC stuff, they actually recommend a 10 amp Power Pro unit for running large scale trains. The power cab is limited to about 2 amps, and we can get away with it on these displays because we're running small engines, very lightly loaded, and only one engine moving at a time. So actually most of the time the amperage on this thing is below 1 amp. Hello, I'm James Ingram. We hope to set up this little demonstration at the upcoming DGRS meeting this at the end of September. We've got a detector down here, which is a LGB 1700 track contact, which will be activated by the magnets on the bottom of the Locos. We have 3 large-scale Locos with DCC decoders and sound, and these white cards indicate approximately where they'll stop. These are operating point to point, and I pushed that black one out of the way because it was blocking the camera, but that'll actually start from right about here where this card is. Here's our DCC programmable model train controller, and we have selector switches here. We can run all 3 engines, which we'll do now, or any 2 or any 1 engine. And we also have a switch over here for an announcement, which we'll turn on. That's optional, but we have a speaker which we can have a recorded announcement play before the trains run. We also have what we call a repeat switch, which if we close it, it'll run continuously. We'll leave it open now so it just runs 1 cycle and stops. And we have these 3 LED indicators here, which they call light. It's essentially an LED with a DCC decoder built into it, and they'll also turn on to indicate which engine is running. And we've got here what we call the public push button, and it says push and release when the status light is red. And you can see what we're calling our status lights. There's 2 of them here and 1 there, and they're red. And when somebody pushes that button, those lights will turn to green while the trains are running. And then when they complete their cycle, those lights will turn back to red again. I'm going to push the public push button, which will start everything up. And watch those status lights, they'll change to green. first engine ran to the far end of its run. It'll wait about 4 seconds, then the second engine will start up. And this is programmed so when they go over the track contact, the whistles blow for 3 seconds. Now that's the second locomotive. Now about 4 seconds and the third one will start up. And you can see those locos are stopping about where those white note cards are. Each engine runs in its own path, so to speak. And we're just using time delay to control where they stop. It's very simple, actually. Like the first one coming back, we say maybe run that back 5 seconds past the detector. And then the next one, which is running now, we can say run it 3 seconds past the detector and stop. And then the last one we can say run it 1 second past the detector and stop. So it gives us different stopping distance, which will keep them separated. And you notice the status lights are written like that. That indicates engine 1 is running. Blinking light indicates reverse. Now that's the end of the sequence. It'll wait for 4 seconds and you can see the status lights all change back to red. And so this system will sit here and wait until somebody pushes that push button to start it again. Or as I mentioned earlier, we can close what we call the repeat switch. We'll just keep running it continuously. But as we sit here now, I'm going to turn the announcements off. So when I push that button again, the trains will start, but without the announcement. You see the lights went to green. And that's starting another sequence, so it'll just keep doing the same thing it did a minute ago, over and over. This is earlier video 829, where we ran 3 O-gauge trains on a point-to-point track in a similar manner using a single detector in the center of the track. This did vary in that we used several smaller programs, whereas in this video 850 we're using one large program with selector switches to select which locos we want to run. I'd invite you to compare the 2 programs if you're interested in doing this. The documentation is all on the AutoControls-dot-org website. Here's earlier video 837, where we were running 4 O-gauge streetcars on a point-to-point track, a longer track, and we used 2 detectors, 1 at each end. If your track is too long for a single detector in the center, then you can put a detector at each end, such as we did in this video. The program is almost the same, except you've got to change the input number to match the second detector when the cars are running in reverse, and just adjust the times. The multi-part series Video 816 tries to help you do some very simple exercises with this programmable controller.